So you had graphs, if you can find those graphs as well, just so you can kind of look at your graph and the graph that we did. Sorry. Wanted to try and grab this graph so that I had a nice graph. Okay, so looking at 25. 25 was similar to the questions we did yesterday, trying to get the information, the important parts to graph. So starting with the y-intercept and then finding the x-intercept. Mariella, how do we get a y-intercept?
You plug in x is 0.
Yeah. And if we do that, Mariella, what do you end up getting?
It's 4 over 0 and 25.
Yeah, you end up with 4 over 0, not 4 over 4. And she said that's undefined, so that means there aren't any x or y-intercepts. So there aren't any, because 4 divided by 0 doesn't exist. So no y-intercept, it's never going to cross the y-axis. The next step, the x-intercepts. We take the top and the y and set it equal to 0. And then you're solving for x. What is your x-intercept? What? Say again? Negative 1. So if I divide out the 4, I end up with 0 equals x plus 1. So as an ordered pair, because it's a point, we have negative 1, 0. So no y, but an x-intercept at negative 1, 0. What's the next thing we find? What else do we need besides intercepts? Kelly. Yeah, the asymptotes. So let's start with the vertical one. Take the denominator, set it equal to 0. How many x's are in the denominator? 2. How many x values would you have then that are undefined? 2. Each x value can make an undefined fraction undefined. So the first one would be 0, which would create my asymptote at x equals 0. The second one would be 4, so I'd have an asymptote at x equals 4. Both of them could be undefined values because I could plug a number in for x and get 0. I could plug a number in for the other x with the 4, and 4 minus 4 is still 0. So both of them give me undefined values. So the reason we don't have a y-intercept is because there's an asymptote at x equals 0. The last part is to find the horizontal asymptote, and that would be looking at the powers. Mackenzie, what's going on with the powers in this problem? Yeah, so even though it's not written as x squared, we could FOIL that bottom or distribute the bottom, and you get an x squared on the bottom. So Mackenzie, that means y equals 0. So y equals 0.
So, never mind.
So now I have all the information that we need to use to try and graph this. Probably need to look it up in the graph to make sure you understand what's going on in the graph. But this is my only intercept, and that's it. There aren't any other intercepts. There definitely has to be more going on in the graph. So I know that from an asymptote, it has to skim along the asymptote. It goes through the intercept and kind of just like curves along it underneath the asymptote. It's allowed to cross a horizontal asymptote if there's an intercept that's on the horizontal asymptote. A horizontal asymptote doesn't make the graph undefined, it just forces it to have a behavior of going to a negative infinity or going to positive infinity. So skims along the vertical, crosses through just barely, and then it like just skims underneath it. On the other side, there is not an intercept there, so it just stays above it. It's not going to cross through it, it just stays above. And again, it skims along going to infinity. That's the definition of an asymptote. A horizontal asymptote is when x goes to negative infinity or positive infinity. And then the last part, what's in the middle? Connor?
Upside down parabola.
It's an upside down parabola. So check what you have in your calculator. I would say it might be easier in the calculator to plug in the equation with like the 4 distributed through, the x distributed through the denominator, and making sure that you have grouping symbols. But it is a parabola, and because it's a parabola has a maximum value. That maximum value is important when you're graphing, and if I remember correctly, it's at like 1.3 and negative 2.6. 2? I don't have it out. 6.2?
I got 0.6.
So, little parabola underneath, just past 1. Its max value 1.3-ish, negative 2.62. But don't just randomly draw a U somewhere in between those. Have a calculator. You have a button that's max and min. You can find that value with the max and the min function of your calculator. Questions? So if you could keep that on the corner of your desk so that I can try and circulate around as we're working through some of the problems. Just keep it open on the side of your desk. We're going to go through 2 more graphs. Pretty much all of the same information, but we're throwing in that final asymptote. Doesn't have to be vertical. I could have a horizontal, and then our final one is the slant asymptote. So, in your packet, if you will find section 2.2, part 2, page 54.
What page?
54. So at the top of page 54, the little statement says, in addition to vertical and horizontal asymptotes, there are also slant asymptotes. These 2, you will never have both. You either have one or the other. Because a slant asymptote only happens in a certain condition. So there will not be a horizontal asymptote if there's a slant asymptote. So the 2 conditions for slant asymptotes. The first one goes off of what we were talking about yesterday with the hole in the graph. There can be no common factors in the numerator and the denominator, between the numerator and the denominator, however you want to say that. And I'm going to abbreviate. Because if there are common factors and we have that piece that cancels, it's no longer a rational function. So, no common factors, it must be a rational function. The second part, or the second condition that must be met, is that the degree of the numerator must be 1 more than the degree of the denominator. And only 1 more. So the power on the top is exactly 1 more than the power on the bottom. So why wouldn't you have a horizontal asymptote? Take that.
It would be 0. Or it wouldn't be
There wouldn't be 1 because the power on the top is bigger. And when the power on the top is bigger, the number on the top is getting bigger. And quicker than it would be on the bottom. So it's going to eventually just keep going to infinity. So there's no horizontal asymptote If the power is exactly one more than the bottom, then there's a slant. If it was more than one more, so if this was, it's supposed to be a cube, x cubed minus 1, then there wouldn't be a horizontal and there wouldn't be a slant. I just have a vertical. So the top, so this one is no ha, how about no, yep, or the SA. This one has a slant asymptote.
So there can't be a vertical one, there just can't be a
Correct. So the vertical one will always be there because it's a fraction. Any fraction will always have a value that's undefined. So there'll always be a vertical. It's the other two that have to match certain conditions. They don't have to have them. Questions on that? We are going to calculate a slant asymptote by dividing. Of course. So that like division kind of appears through different concepts as we work throughout the year. You can use long division if you like long division. You can also use synthetic division. I'm guessing you'll use synthetic division just a hunch. So I'd like you to see if you can work through those first 4 pieces. Find the y-intercept, find the x-intercept, find the vertical asymptote, find the horizontal asymptote. And then we'll talk about getting the slant asymptote. See if you can just work through those 4 pieces because that's what the homework was last night. That's what we did in the notes. And you find those 4 pieces of information.
So what 0 would we use to do this?
The denominator.
The denominator.
So you should have a 0, 2 for the y-intercept. How do you find the x-intercept?
Set the numerator equal to 0.
And when you do that,
We get 2 and negative 1.
yeah, because you got to factor it. So 1 y-intercept, 2 x-intercepts. The vertical asymptote is positive 1, not negative 1. And then the numerator has a larger power than the denominator, so there's not a vertical asymptote. Questions?
How do you say there's a saw?
How do you say there's a saw?
Yeah, like you could say like the vertical asymptote is 1. But how would you?
Because if the numerator is 1 more power than the denominator. That would be like the reason.
Yeah, but so what would the number be?
Oh, we're gonna do that now.
Yeah.
So when you're dividing, you usually try and break down the bigger equation, the bigger number. Where is our bigger equation right now? In the numerator. Usually, we always divide by the denominator, because that's how you divide. This fraction is called an improper fraction. When you have a bigger number or equation on the top compared to the bottom, it's called improper. So we're going to break down the numerator, where every other problem we've done, we've actually broken down the denominator. So we're taking the coefficients from the numerator, which would be a 1, a -1, and a -2. The divisor now, what we're dividing with is down there. So we're trying to break up that top. And what would you be dividing with? 1. Yeah, it works the same way. We're dividing with 1. But usually the bigger part's in the denominator. We're trying to break the numerator into that. So it's kind of the opposite. It's
Are
Kevin.
you supposed to get 0 or?
You're not going to get 0 because it's not a factor. So we're just trying to break it down. So if we divide here, bringing down the 1, 1 times 1 is 1. Adding, I get 0. And then I get a -2. This -2 is the remainder. No, we're not going to get 0. Because we're not necessarily showing that it's a 0, or we're not showing it's an x-intercept, because we're just trying to find the slant asymptote. This -2 is an extra piece of the equation that we'll talk about once we get into something called partial fraction decomposition, which is not there quite yet, but it's a lot of fun. It's like one of my other second favorite things to do. So, that'll be that. I can't, like this -2, it's part of the equation, but it doesn't affect our asymptote. Our asymptote comes from whatever is left. So what does that remaining piece represent? If I started with x squared, what does the 1 and the 0 get attached to? What variables does it go with? So the x, or the 1 goes with the x. This is mx plus b form. It's a line. It's an asymptote. X equals vertical line. Y equals horizontal line. But y equals could also be a diagonal line. So our slant asymptote is a line in y equals mx plus b form. And in this case, it's just y equals x. So we're going to have a slanted line when we graph this. So if you can take your points and graph it, I'm going to try and get a better graph. I erased it before. Come on. So taking this information and plotting all of the points that we have, y-intercept, x-intercept, asymptote, and then you need to graph y equals mx plus b. I should have a dashed slanted line. 1x plus 0. So my y-intercept for my slanted line is 0. My slope is up 1 over 1. So y-intercept, 2 x-intercepts, and then I need to graph. I know my graph has to go through the intercepts, and it has to skim along the asymptotes. The definition of an asymptote, whether it's horizontal, vertical, or slanted, still that forces the graph to go to infinity. So if I connect my dots over here, asymptote skimming along, connecting, skimming along the other asymptote. So it skims along the slanted one, goes through the intercepts, skims along the vertical one. Here's my other intercept, so skimming along and moving along. Oh, it kind of does look like a butterfly. Questions? So still thinking about domain and range. The domain doesn't change. The domain still goes off the vertical asymptote. So my domain would be -infinity to 1 and 1 to infinity. That part will never change just because I slant my asymptote. What would the range be? Looking at the whole graph. Taylor, what would the range be? Because vertically, it's going down forever. Yeah, I know it's skimming this way, but it's still going up forever as well. Questions?
These types of graphs always have the same range.
No, they will not. The next one is different. So we're going to see how it changes. So looking at the second graph, working through exactly the same information. Get your y-intercept, get your x-intercept, find the vertical asymptote. There won't be a horizontal, but see if you can now find that slant asymptote.
But
So you should get 0, -1 for your y-intercept. What do you do for x? Odette? And you need to use the quadratic formula, Odette, because it's not factorable. So nice job, Odette. So there is not an x-intercept, not because you can't factor it, but because when you plug it in the quadratic formula, you end up with a negative underneath the square root. Taylor.
Never mind.
You sure?
Yeah, I was gonna ask why can't you do AC grouping, and then I realized that nothing multiplies in 4 halves -2.
Exactly.
Oh
No, you're good. I'm glad you. 4, there aren't any factors of 4 that will divide and break it into 2. So that part doesn't work. So no x-intercept. There we go. The vertical asymptote is at 1. The horizontal one doesn't exist. And the slant asymptote, you should have found 4x plus 2. So use synthetic division. You're still dividing with a 1. You have 4, -2, and 1. So it ends up being 4x plus 2. So this mx plus b has a steep slope. When you put this in your calculator, Abby said, will they always go to negative infinity? And I said, no. Because this graph connects with the y-intercept, goes slightly above it. You will need to find this max, and I know I'm pretty much out of time, but you're going to need to find that max. There is another part in your calculator that does not necessarily exist when you look at it, but if there's a bottom portion, there is also going to be one to match it at the top. And that top has a max, it's like 12, or a min at 12 something, 12.9 I think, 12.8, 1 point something. So this range would go up to the max, and then it would start at the min, and then go up to infinity. I know you guys are packing up, but in your packet on pages 57 and 58, it's starting to get you to review 3 graphing problems. On page 57, don't do letter G, where it says list the intervals of increasing. So do not do letter G.
Yeah.
So the first 6 parts are really what we've been working on: the intercepts, the asymptotes, the domain, the rate, and then graph that. And then there's a couple of problems in your book for you to graph. If you want more graph paper, it's up here. Tomorrow we're going to review for the test on Monday.
What is today? Wednesday?
Today's Wednesday.
Today's one is
Wow.
next day.
Wow. It just doesn't feel